Okay, today's lesson is called Molecular Formula. It's going to be really fast because it's only like one extra step from yesterday's. Definition of molecular formula is the actual number of elements in a compound. What it is, it's based on empirical formula. It just weighs more. It's not a highly scientific definition. But examples would be, so like these would be empirical formulas, right? Because there's like one of something, so it's already like reduced. Molecular formulas of those formulas are these. So like this formula is 6 times each one of these. This one is 2 times, C2, this one. You can have molecular formulas that are the same as empirical formulas. There's no multiple of NH4Cl, which is ammonium chloride. It just isn't. So based on that, here's our how do you find molecular formula. So, here's a couple examples. So here's our formulas, just identifying empirical or molecular, because that's what you're going to have to do today for practice. So C2H8 looks like it could be reduced. So if you can reduce it, it's molecular. H2O, it's only a 1. That's automatically empirical. NaNO3, there's 1 Na and 1 N, so empirical. This one, P6Cl8, is molecular. So the easy way to identify is if you can reduce something, it's a molecular formula. Like P6Cl8 can be divided by 2. C2H8 can be divided by 2. If you can't reduce it, it's empirical. So essentially dead giveaway, if you see anything, if it has one element, if there's just one of something, 1 Na, 1 N, it is automatically empirical. So next, molecular formula. How do you find molecular? So molecular formulas are determined experimentally. So mass of molecular formula is always given to you in the problem. So molecular masses are multiples of empirical formula masses. So like, up here, that this molecular formula is a multiple of that empirical formula. So how do you figure out what that multiple is? Molecular mass is the multiple is you do the molecular mass, which divided by the empirical mass, and it's going to give you a whole number. A couple extra bullets here. This number is how many times you multiply the empirical, it's that when you solve them, you multiply that number by the empirical formula. But in real life, this is how many times bigger the molecular mass is than the empirical mass. This one, molecular mass, this number is always going to be given to you in the problem. So you never have to calculate that, but you might have to calculate empirical mass. So I got 2 examples. So example number 1, I tell you, see, look, determine the molecular formula of a compound that has a mass of 181.5 and an empirical formula of that. So the mass in the problem, the grams per mole, is always going to be the molecular formula mass. And then it gives you the empirical formula. So this one's a shortcut question. So then you just, the first step is to find the molar mass of the empirical formula. And that is, 2 C's, 1 H, 1 Cl, and it's 60.483. Then step 2 is to figure out the whole number ratio. So do the molecular mass divided by empirical mass. So again, the top one's always going to be given to you in the problem. 181.5 divided by, and then it's what you just calculated. And that is 3 times bigger. So then the trick is, then you multiply that number by each element in the compound. So C2 times 3 is C6, H3, 3 times 1 is 3, C3, yeah, right. So it's C6, H3Cl3. All right, next example it is curiously similar. Oh, well, here's the question. So it's the same steps, but you need to calculate the empirical formula first. A couple of things to note in this problem. molecular mass, like it says molecular mass right there. So that is, I'll just go back to the one before, that's always your top number. These other numbers are the masses of each individual element. So it's the same steps, but then the first thing you have to do is to use these numbers as your grams to find empirical formula. So starting numbers, 4.04 grams of nitrogen, and again, empirical formula, step 1 divided by molar mass, percent to mass to mole, nitrogen, moles of oxygen are 0.716, and then divide by smallest, 288 divided by 2, that's 1, 7.16 is 2.5. So I picked this one on purpose. So mass to mole, divide by smallest, and now it's not a whole number, so multiply till whole. So again, 0.5 is times 2, or 1 times 2, 0.5 times 2.5 times 2. So 2 ends 5. Oh, so the trick is then that's the empirical formula. Now you still have to take this number in the problem and, well, figure out the molar mass of this guy first, and then divide the molar mass. So I did that already, 2 times 14 plus 5 times 16, that's what that is. So the molecular mass divided by empirical mass is 216 divided by 108, and gee, that's 2 times bigger, so that 2 is multiplied by each of these elements, so N4, O10. So whenever you pretty much, usually if you have to find empirical formula and molecular formula in the problem, it is going to say what is the empirical and molecular formula of the compound. And I'll try to double check and make sure the molecular, or it's going to say a molecular mass. Like, it's going to be completely obvious like that. So it's always going to be your top number. And I'm going to make sure grams per mole, so you know that's that molar mass. And then the other numbers then are going to be how you calculate empirical mass. So I'm going to try to be completely obvious like that. So, okay. Good luck.